Okay, physics class, let's talk about vectors quickly here and cover some important ideas. A vector is a quantity that has both what? Two things. The first thing is it has magnitude. Now, scalars also have magnitude. So what is magnitude? Well, another word for magnitude would be value. So what's the second thing a vector has that makes it different than a scalar? Well, it also has direction. So right here we have the idea that a vector has both magnitude and direction. Let me talk to you first about this idea of direction. Okay, so vector direction. First of all, vector direction is measured as an angle. Now, not just any angle, but it's an angle measured from the x-axis going counterclockwise. What the heck is counterclockwise? Well, if this is a clock, clocks go around this way. Counterclockwise, the direction we're talking about is that way. Counterclockwise. Let me show you what this means. So right here I have a vector. Now, I want to figure out what direction that arrow is pointing. And currently, I don't see an x or y axis. So what I do is I draw an x and y axis right at the base of that vector. Now, the angle that vector makes with the x-axis going counterclockwise is that angle right there. That green arrow is the angle that vector makes. We'll just generically call that angle the Greek letter theta. What is that angle? Well, you could grab a protractor and you could measure it. That's how you determine the direction of a vector, by specifying the angle that makes from right here, this positive x-axis. What if we had a vector looking like that, and we wanted to figure out what direction that vector was in? Once again, I construct an xy axis at the base of the vector, and I measure all my angles from this positive x-axis right there, going counterclockwise around like that. You could grab a protractor and you can measure that angle, and that would be the direction of that vector. Now, there's other ways to do this, to figure out the direction of the vector, and those other ways are using right triangle trig and methods like SOHCAHTOA. And if you've heard of SOHCAHTOA before, well, this would be somewhat familiar. I'm not going to go over it in this video right now. I'll go over it in a different video at some point. But another way to go at this is with SOHCAHTOA if you don't have a scale drawing and a protractor. That's it for now.